Hello everybody. Tonight's flipped notes is where we are really going to start to understand and have a chance to explore the real world connections that domain and range has to situations that we see all around us. To get started though, we're actually going to have a little bit of a warm up here with some skills that we have practiced in the past. Numbers 1, 2, and 3 are good opportunities to remind ourselves how to find domain and range of a discrete function, meaning it's countable. So to help myself out, I could start off by labeling this as xy to remind myself that for the domain, I'm going to need to pull each of these x values. Before I start writing them down, I know that I'm going to want them in order of smallest to greatest. So let's see, 2, -3, -4, and -3. I'm going to write -4 first. And as I do that, I'm going to lightly cross it out so I can still read it. So I guess I should slash it out the other way so it doesn't cross out the negative. But kind of gets it off the list, so to speak. Next comes -3. And we remember that for domain, we only list them once. So I'm going to cross out that -3 as well. And then 2. Now we're going to go list all of our y values. So that would be, the smallest one is -1. Oh, I didn't cross off 2. Okay, so now I'll change colors here. -1, 0, 7, and then 9.
Attention please, loose ends, save off.
And then I'll close the bar.
Save off, front lobby.
So I have my domain and I have my range. Now to consider whether or not it's a function, I might actually now need to take my eraser and erase my slash marks so that way I can look at these ordered pairs again. Grading your quizzes, I saw a lot of people identify that it's a red flag if I see an x value repeating. So here I see that -3 repeats. That's definitely a red flag, but I can't say no because -3 is listed twice. It's the fact that -3 is sent to 2 different y values. So no, because -3 is sent to 2 different y values. Or you could say -3 is sent to 0 and -1. So being very clear with this language that it's because -3 is sent to 2 different y values. That's why it fails. The reason it's important to specify that is because if this said -3, 0 and this said -3, 0, this would actually be a function because -3 is being sent to 0. It's like plotting one ordered pair right on top of the other. Similarly, if this had said -3, -1, and this had said -3, -1, I would have been okay. Moving on to number 2, please press pause and list the domain and range and determine if it's a function by yourself. When you're ready, press play and we will compare our answers. So domain is going to be x, my range is my y values. So it's nice with a table, my x values are already all in together for me, and in this case actually in order, smallest to greatest. And I close it. And then my y values, these ones are not in order, so let's see. My smallest is -5, so I'll put that one first. -2 is listed twice, so I'll only put -2 one time and cross both of those out. And then 6, and then 11. Is this a function? Right away, when I look at my x values, I see that there's not even a single x value repeated. So automatically, this is a yes. You could put x does not repeat, or you could put each x value is sent to 1 and only 1 y value. There's many ways to say the same answer, but as long as your sentence is something like that. Number 3, I'm actually going to leave for you. So there's 1, 2, 3, 4, 5 ordered pairs. So you need to actually go find those 5 ordered pairs. I'll kind of set up a little list over here for you. And then once you have that list, you'll be able to tell me the domain and the range. And then there's actually a couple different options in terms of determining if it's a function, because you technically have the graph to look at and the ordered pairs. So I'll be interested to see what you come in with for number 3. Looking at number 4 and 5, this is actually a little bit of a typo here. Please make this a solid dot. These are not supposed to be arrows, so please make this a solid dot. In future classes, this will actually already be a solid dot. So if it is, your workbook is in good shape. If yours had arrows, please make them solid dots. All right, so now we're starting to look at real-world data. This first one is about Alaska crude oil production. So here's a picture of an oil platform in the middle of the ocean. And we're looking at the production from these years. And notice that the Y values are in 1,000 barrels per day. So like 200 actually means 200,000 barrels per day. And this is 600,000, 800,000. So looking for the domain in interval and set notation, I'm looking at the years. Notice 1975 is here, and it counts. This isn't 1976, it's 1980. So if I look, 75, 80, 85, 90, 95, the years are going up by 5s. So if I were to go backwards, roughly this much space, if I were to go, let's see, that's kind of like not quite the same amount as 5 years, maybe 1973? 1972 would also be acceptable, roughly there. And then 2005, same thing, maybe 2008. So we purely need to use our ability to analyze the scale to decide that this is not quite minus 5 years and this is not quite plus 5 years. So for the interval, that's going to be 1973 to 2008. And then for our set notation, we should be pretty rock star amazing with our setup. And then I literally just drop in those 2 values, 1973 to 2008. And we do need lines underneath because we can be equal to those years. Now let's look at our range, the values for the barrels, the number of barrels per day that's being produced. I look, and we could argue that that's maybe a little less than 200,000. If you put 200,000, I would be fine with that, or 200, since the scale is thousands per day. But if you put like 190, I would understand that. So you can either put 190, because that's a little less than 200, or 200. I would take either. Now, when I'm looking for this solid dot, let me make this a little clearer for where this dot's going to be. The dot's going to be right there. So if we trace that over, it's at 600. But that value actually means nothing when it comes to the range, because if I were to take my pencil and come in from the bottom, I get what we just talked about, the 190 or the 200. But then I'm coming in from the top. And when I come in from the top, I'm at 2,000. So I put 2,000 here. And then I have my 2 values. So now, for the range, I'll put a bar, and then we just can get our setup, as always, in the middle, leave some space, and then drop in our values. So this is going to be 190, and this will be 2,000. We need lines underneath both of these because we can be equal to those values. So don't let this endpoint fool you when it comes to the range. This value mattered for the domain. But for the range, we still come in from the bottom and the top. Is this a function? Yes. Passes VLT. So now that we just did number 4 together, give number 5 a shot. I'm going to make this dot a little smaller. Ignore the arrow. The dot's going to be right there. And go ahead and give it the domain and range a try on your own. When you're ready, press play. So this is all about world population increase. And pay attention to the fact that the Y values are in millions of people. So what that means is that 10 is actually 10 million people. Okay, so now press pause and give it a try. So when I use my pencil, let me get my pencil back on the paper. Oops. For the domain, we're going to come in from the left and the right first. So when I come in from the left, I see, one, I notice that my graph doesn't actually start over here at that 0 initial value. It actually starts at 1950. So there was no need to count backwards at all. So it's going to be 1950, comma, and then when I come in from the right, remember this is a solid dot, I'm at 2000. Those both get brackets because it exists at that value. And then dropping this into our set notation, I put 1950 right here and 2000 right here, bars underneath both. Now for the range, I'm going to turn my pencil sideways. Coming in from the bottom, we're going to have to use our powers of reason here, because when I trace this over, it's definitely not 50 and it's definitely not 40. We could argue 45 or 46, somewhere halfway in between. I would accept 45 or 46. And then when I come in from the top, 90. And I'm done. All I need to do is drop this into my set notation. And just to draw attention to what I just did, I'm not sure if anybody kind of noticed that I literally just wrote it straight across as if it was a sentence. So I did Y bar 45, and then I know what the middle looks like. So to me now, I can kind of like write this as if it was a sentence, left to right. If it still helps you to do this first, leave a space, Y, and then put this middle piece, leave a space and close it, do that. If we've kind of stepped up to just writing it left to right correctly, that's awesome too. Whatever works for you. Is this a function? Yes. Passes VLT. So real world data like this exists all over the place. Start paying attention when you see the news on how many graphs they'll show as part of the news broadcasts. Every graph you see has a set of X values and a set of Y values. Let's look at our first real world scenario. And this is real data, not just made up numbers. Water pressure P can be measured in atmospheres, where 1 atmosphere equals 14.7 pounds per square inch. So what this means, guys, is that when you're swimming, right, and you're at the top of the water, you really don't feel any pressure on you. But the farther you go down in the water, you will actually feel pressure. Your body will feel a difference. And it's measured in 14.7 pounds per square inch of pressure on your body for every atmosphere that you go down. At sea level, the water pressure is 1 atmosphere. So you don't really feel that here at 1 atmosphere. It increases by 1 atmosphere for every 33 feet in depth. So if you think about that, 33 feet is like 3 stories. So imagine that you're on a 3rd floor of a building. The distance of the 3rd floor to the ground, when you travel that distance underwater, you feel 14.7 pounds of pressure on your body. So we have this model. It says, therefore, the water pressure can be modeled as a function of the depth, the D. As soon as we have a variable defined, let's underline it by this equation, and let's highlight the equation given. When we're given a model, we're always going to highlight it so it stands out. We're also told something about the domain. Check that out. Let's highlight that as well. And let's label this the model, and label this domain. Let's answer these questions. So first we're asked to define our variables. Well, while I was reading, I underlined depth D. So I know that D is depth in feet. And what about P? Well, if I repeat this last sentence, it says, therefore, water pressure can be modeled. So this model is modeling water pressure. We kind of make a connection, P for pressure. And that pressure is pounds per square inch. You can either write out square inch or just put inch squared, inches squared. This step seems to catch a lot of people, and I'm really excited that we're going to have a chance to work on this together, because if you take a step back, we have done no math yet whatsoever to answer this question. We've just been reading for information. So that's something we're going to work on together and become pros at reading for information. Okay, next, in part B, we're asked to determine the domain and the range. Well, now that we're dealing with real-world scenarios, domain and range actually has a meaning. So in the past, we would always say domain is X and range is Y. And that is still the case. But now my inputs mean something and my outputs mean something. My domain, my X values, means my depth. So above domain, please write depth in feet. And above range, please put water pressure, because that's my output. Those are my Y values. I'm actually going to move this over a little bit. Water pressure in pounds per square inch. So now that we have a real-world meaning, domain is no longer just domain. It's about the water pressure. Or excuse me, I'm sorry. Domain is no longer just about the X values, it's about the depth. Range is no longer just about the Y values, it's about the water pressure, the resulting water pressure. Reading for information, we actually don't have to do any work for the domain. It gave it to me. So we're literally actually going to just drop it right in there. My domain is given to be D is between 0 and 130, which really means that D, the depth, is between 0 feet and 130 feet. I would accept either of these representations. I would more lean you towards actually including your labels, because then 0 is not just 0. It actually has a meaning as 0 feet. And the 130, same thing. It's not just this number. It actually represents 130 feet. So it means that your depth as a diver is between 0 feet and 130 feet, which it makes sense for there to be a restriction on your depth, because outside of like taking a tank below the water, a human being can only go so far before they would actually really be physically hurt by the water pressure. The range. Well, if I reread, I was not told anything about a restriction on P. I don't see any kind of inequality like this anywhere here. What are we going to do? Well, we have this model. I know I kind of drew over it, so let me move my circle over if I can. I have this model. The model is going to be the key to getting my range. So I'm going to rewrite my model. P equals 0.03D plus 1. Let's take a step back and really think about what domain is. Domain is the smallest and largest x value. Each x value has a corresponding y value. So if I'm looking now for the smallest and largest y value, we are going to plug x values into P equals plug x values into P equals 0.03D plus 1. This is the key step here to actually get these y values. So this is going to be the key. We've got the smallest and largest x value. We're going to plug them into this model to find our y values. So we're going to do two evaluations. We're going to do P of 0 and P of 130. I pulled those values straight from the domain. So P of 0, using this as my model, will be 0.03 times 0 plus 1. Well, anything times 0 is 0. So that becomes 0 plus 1, which is 1. And then here, P of 130, that's going to be 0.03 times 130 plus 1. And this is where we'll take out our calculators to do 0.03 times 130. So I'm taking mine out now too. And don't just watch me do this algebra on the calculator. I mean, you can't see me using my calculator, but I'm telling you that I'm using my calculator, so you should too. If your calculator is not out yet, press pause, go get it, and you do 0.03 times 130 with me, please. So we do 0.03 times 130. Press pause, by the way, if you need to get your calculator. We do 0.03 times 130, and we get 3.9 plus 1, which is 4.9. So we just plugged in the values of the domain to find the values for the range. That's it. Pretty awesome. So big picture, when you're given the domain, plug those into your model to find your range. Let's practice some more. Number 2. During an epic snowstorm, it was snowing at a rate of 4 inches per hour for 5 hours. This can be modeled using the function. Ooh, check it out. Gives us a model. Let's highlight it. Y equals 4x. Define the variables. Okay, well, let's really think about what we're talking about. We've got the snow. It's falling. It's very exciting. Can't wait for some snow days this winter. Just a couple. We want to get out early in June. But it's snowing, and I see that it's measured in inches. And I also see time is mentioned as hours. So from science and math from last year, I hope that we remember time is always the independent variable. So if I were to put a label on here, it would be time in hours, and x will be time in hours. Once I know how much time has gone by, I know how much snow there is, and the snow is measured in inches. Notice I'm kind of doubling up here. As soon as I have a label, I'm also putting it on my graph. And it kind of makes sense because you don't know how much snow has fallen until you know how much time has gone by. Graph the function, plot at least 2 points. Well, from blast from the past, from algebra 1, y equals 4x. So that means that my slope is 4. My y-intercept is 0. There's an invisible plus 0 that's not written, but I could write it. So plotting 0 here. Ooh, look, I don't really have a scale here. So maybe we count by ones. So 1, 2, 0. 1, 2, 3, 4, 5. This would be 5. 6, 7, 8, 9, 10. 11, 12, 13, 14, 15. And maybe we count every other box of 1. 1, 2, 3, 4, 5, 6. Now if that didn't actually work out and we needed to count by ones, since we're doing our math in pencil, we could erase this and go 1, 2, 3, and so on. So let's see. Using our slope, 4 divided by 1, that's up 4, right 1, because these are both positive. So we're going to go up 1, 2, 3, 4, right 1. So because I counted this 2 boxes to be 1, notice I moved over 2 spaces. Up 1, 2, 3, 4, right 1, 1, 2, 3, 4, right 1. And I realized that it said plot at least 2 points. We've now plotted 4. So I can take a straight edge. If you don't have a ruler at home, you can use an index card or take a piece of paper and fold it into 4s, and then that gives you a nice straight edge. We have our graph. Part C says, determine the domain and the range and describe what they mean. Check out all that snow. Okay, so let's go back and read. If I read carefully, it says, during an epic snowstorm, snowing at a rate of 4 inches per hour, that was the rate of change. Notice this right here. It says for 5 hours. It makes sense that we're given a time frame, right? Because snowstorms don't last forever. They only are for so long, maybe sometimes for a couple days. This one was for 5 hours. Now I have to ask myself, is that 5 hours a value for the domain or the range? Well, let's say I'm not sure. To help myself out, I want to get some real-world labels for domain and range. So if I look, I know domain is about x, range is about y. Domain, I have already labeled my x values to be time in hours. And I know that the range is about the snow in inches. As soon as I put that label, I'm like, oh, look, 5 hours, that's a restriction on the domain. So if I do my setup for domain, leave a bar there, a space, x is between 2 values. If it's snowing up to 5 hours, I know that 5 goes here, because that's the most number of hours. I'm not really told a starting time, but I can kind of reason. In the real world, there's no such thing as negative time. So 0 is the real world restriction on the time. It's snowed between 0 and 5 hours. So what do the intervals mean? It's snowed between, or from, it's a shorter word to use, from hour 0 to hour 5. There's like 18 different ways you could say that, maybe not 18, but many ways to say that sentence. It snowed for up to 5 hours. It snowed between the 0 hour and the 5th hour. And then for the range, I'm given the domain. So remember, this is my smallest x and my largest x. Smallest x, largest x. I'm looking to find the y values. I have this awesome model I was given, y equals 4x. So I'm going to take the domain values, plug it in to find the range. So we need to do f of 0 and f of 5. This is a super tiny equation, so it's awesome. We're going to do 4 times 0 for f of 0, and we get 0. And then f of 5 would be 4 times 5, and we get 20. I'm going to pause right there just for a second so you can look at that. Again, we used our model. We plugged in our smallest x and largest x to calculate our smallest y and our largest y. If this was the first snowstorm of the year, this makes sense that at 0 hours, right? This is 0 hours. We have 0 inches of snow. There was no snow on the ground. After 5 hours of snow, there was now 20 inches. Check out that snowstorm. How awesome would that be to get 20 inches of snow? So in terms of a meaning, the snow fall total is between 0 and 20 inches. And again, there's so many ways you could write that. As long as you're telling me you understand that the possible inches of snow is between 0 and 20 inches, any way you want to write that is acceptable. And we are done with part C. This will conclude our flipped notes for tonight. And tomorrow, for our debrief, we will be doing number 3 together. Nice job on today's notes, and I look forward to seeing you tomorrow and working on the next question. Have a great night, everybody. Bye.